I have a question that between hypochlorous acid and perchloric acid, which one is a stronger acid? So you can answer this by comparing the Ka. And to explain the Ka or explain this dissociation, the behavior, you have to look at the hydrogen bond system. Okay? So a drawing for you here is the hydrogen bond between water and the hypochlorous acids, right? So after dissociation, you have hydronium ion and hypochlorite ion over here. So you have to draw the picture of the next system, perchloric acid, okay? And you will see the difference between these two systems. And you can then answer the questions directly, okay? So if you haven't done it yet, okay, just take your time, do it right now. But if you finish, then we will look at the correct answer right now. So from the picture over here, as you can see, you have hydrogen bond, okay, in the system. And this is a kind of equilibrium. The dissociation is better than water. Because if you think about the water, you have H instead of Cl. So if you change the H to Cl, that means this group has higher En. And then it turns out to be this hydrogen is more positive than the water. So if this hydrogen is more positive, then this interaction is stronger and go forward better. Again, from the right hand side, the negative charge of oxygen interact with the H plus over here. But if you have Cl instead of H, for hydroxide, you have hypochlorite. Okay? Cl has higher En comparing with the hydrogen atom. So the electron clouds on oxygen is not as dense as in hydroxide because Cl somehow he can pull electrons from oxygen a little bit because anyway Cl has less En comparing with the oxygen. But anyway, again, Cl has higher En than hydrogen atom. So that means the negative charge of oxygen here is less than the negative charge of the hydroxide. So that means the interaction between negative and positive is weaker. And then the reverse portion is less than the water. So forward better than water, backward less than water. Then the Ka of this is higher than the Kw of water. Kw of water is 10 to minus 14. But Ka of this hypochlorous acid, I have the number over here. 4.5 times 10 to minus 8. So as you can see, it's stronger than the water dissociation. Now, we have to compare the system with the perchloric acid. So, I will jot it down here. HClO, right? Ka is equal to 4.5 times 10 to minus 8. Now we're going to look at our perchloric acid. So perchloric acid somehow differ from the hypochlorous acid by you add 3 more oxygen atoms into your molecules. And then your chlorine would be like this. So from here, not only 1 chlorine atom added to water, you add 3 more oxygen atoms. So this is a huge group of very high En atoms stay together, right? So by the En of all these parts, right, it can then take electrons from hydrogen atom effectively. And this hydrogen is very, 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 very positive, right? So interaction between electron pair and very positive hydrogen over here is so strong, and hence the equilibrium go forward drastically because of the very high positive charge of hydrogen atom over here. And on the other hand, after you finish dissociation, you end up with hydronium ion and the perchlorate ion. So the structure of the perchlorate is like this. So with the higher number of oxygen atom, right, very high En oxygen, 3 of oxygen atoms over here. So it can take electron out from this O minus. So the negative charge is very, very low. So with the very low negative charge, then the reverse reaction drops drastically as well. But moreover, this electron or this negative charge can resonance, right, to other places, to this oxygen, or this oxygen. So at the end, if I just shift it to the right, your right-hand oxygen is negative. But it also can be delocalized to the middle oxygen in the center. And again, delocalized to oxygen on the left hand. And delocalizes back up there. So as you can see, the negative charge can delocalize along the structure of the molecules. So this, not only the inductive effects or the induction by the En value, but also the resonance effect makes this oxygen very low negative, right? So the backward reaction is very, very bad. And I have the number here. So, the Ka is very, very high as well. And the Ka is roughly, because it's very, very positive. So we have no exact value, exact number, because it's very hard to do the experiment. But anyway, approximately the Ka is in the positive region again, and even higher than the HCl. And K is about 10 to plus 8. Okay, so it's about 100 million. All right. So that means the perchloric acid is stronger than the hypochlorous acid. Okay, as you can see, and as you can explain by the strength of hydrogen bond. Okay, so this is the hydrogen bond and the applications of hydrogen bond to use as a tool for explain some kind of chemical behavior. In this case, the acidity of the compound, and also we can describe the basicity of ammonium ion, of ammonia, of amines, and everything amide by this kind of intermolecular interaction hydrogen bond as well.